excited to be here. So I'm Amjad Masad, like Brian said. I am not Ken Wheeler. Someone asked me out there if I was Ken Wheeler. I'm not. We look alike. We have the same diet, ribeyes, so it's no surprise that we kind of look the same. But my name is Amjad Masad, CEO and co-founder of Repl.it. It's an online IDE. So before we get started, I'm going to just introduce Repl.it a little bit because I need to sort of set the stage for the problem we're trying to solve here. So simply, it's an online REPL, but that kind of doesn't do it service. Because while it started as an online REPL, it kind of evolved and it became also an IDE, but not this heavy, clunky IDE that we put on the web. An IDE that sort of grows with usage and starts out really simple, really easy, and then as you need the power, it reveals itself. It's also sort of happened by mistake. It's also a platform for hosting code and apps. We're not trying to compete with GitHub. GitHub's great. It's also a friendly community. We think that programming communities tend to, with time, kind of decay and become really unfriendly for especially beginners. So we're focusing on making it really friendly for beginners, people of all ages. I'll give a quick demo. I like giving demos. So one thing, if you go in Repl.it, one thing you might see is the languages page. So we support a whole lot of languages and environment. It's about 50 languages at this point. So if you click at one of the more popular languages, Python, you can see that the IDE loaded really fast. And I can start sort of printing something. So let's say hello Reactathon. It's also a REPL, so I can do things inside the REPL. But let's make it a little bit more interesting. I'm going to go to packages. This is what we call our universal package manager. It's a single package manager for a lot of the languages that we support. And search for one of my favorite Python packages, term color. As you can see, it starts installing right here. And then I can import it. You can see I'm getting really good IntelliSense. I'm not sure if you're seeing. Let me pump that up. So as I'm coding, I'm getting IntelliSense all in my browser. So hello Reactathon. And then color, let's say red. On color, let's say white. And then let's print that. All right. I didn't get the right thing. Oh, I'm missing. Error. So I'm just going to peek definition here. Look at the module, how it's written. Oh, I should write on white. So we're just going to copy that and do on white instead of white. Let's actually make it a little bit more interesting. Let's make it blink. Let's make it bold, too. All right. That's more like it. And one cool thing about Repl.it is that it's also, let's start a new REPL because it's so easy to start new REPLs. It's also adaptable. It'll figure out what you're trying to do. So I have a Flask example here, and it will do the right thing. So I'm trying to build a web app here. So what it'll do, it'll split the console in half and show me the web app. And suddenly, I've also hosted my app. Here's my Hello World app. You can't probably see it. Oh, it's right there, coming. All right. This also works in all the languages that we support. Since this is a JavaScript conference, I should probably do JavaScript. So I'm just going to do it in the REPL here as well. So HB create server, rec res, res.end hello. .listen, any port, 8000, and boom, we've hosted our Node.js server. So the reason I'm telling you all this is not to just introduce the product, but also say that we have this very very dynamic interface that we're trying to build. Originally, when we started writing in React, we thought, okay, we're programmers, we love abstractions, we love this concept of primitives. We can build these building blocks and kind of put them together in interesting ways. So okay, let's build all these components. Like let's build a console component, editor component, a split, a header, a workspace, whatever it is, and then we can put them in the kind of different configurations that we'd want. Initially, it worked out well, but as things got a little bit more complicated, it became a problem. So we notice ever-increasing branching and configuration logic. So if I'm in a web project, it's going to be very different than like a Python project. If I'm in a REPL, it's very different than a GUI application. It's also a very rigid layout. The cool thing about React is that the code looks like the output. And that's great. We love that, right? It's really great. In this case, we don't love that. It becomes really hard to change the layout dynamically. Almost impossible to do it at runtime. There's also no place for non-representational components. So we're thinking about everything in the IDE is sort of UI, but there are things that are not UI. So for every environment, we have this engine that runs the code, right? Whether it's like the HTML engine in the browser, it's the container backend when you're hosting a web app. It's different engines. Those don't have representational components. We want to be able to also compose them. And perhaps more importantly, even though we thought that we had this building blocks, these abstractions, ultimately they sort of somehow leaked and knew about each other. And I'm using this term here called conflicting or conflicted, and I'm borrowing it from Rich Hickey, a famous talk called Simple Made Easy. I actually watch it once a year because it's such an amazing talk because it introduced something that was missing from software engineering. We always thought about modularity in terms of code. I'll split up my code and it'll get arguments and props or whatever, and it'll inherently be modular and simple. But in reality, a lot of times there's implicit connections in the code. You have two Lego parts. Although they're separate, they're kind of thinking about each other. They know the model where they kind of attach to each other. So what is it that we want? Okay, so I introduce the problem. What is it what we want? We want truly isolated components. We don't want this conflicted mess of things. We want an architecture that forces us to really kind of separate concerns. We want an isolation model that allows for sandboxing. So I'm sure you've all had this experience with IDEs where you load a plugin and it crashes the entire IDE, right? Sublime was really famous for that. For us to open up the IDE, it's still early. We haven't opened it up for plugins. But when we do, we want to be able to sandbox that, whether it's in iframes or in workers or even on our servers. We want to be able to have an isolation model where the code can run in different places and eventually kind of all renders to the same place. We want to be able to change layout dynamically, like I showed you, kind of split something in the middle, show popover. That's how IDEs work. The building block should be a plugin. It should not be a React component. React should be reduced in this case to a representational thing. It should be just a view, right? The system should not know about React as a whole. Whereas the original system that we wrote, everything is React, and React drives the whole thing. We want to be able to kind of reduce React here to just the view. So here's a potential solution. We want to be able to decouple layout from React. And so that might be sort of heresy or maybe a controversial statement, right? So we want to take one of the powerful things that React does and actually remove it from React. But in this case, we think it's warranted. I think there are a lot of different applications as well that this might be warranted, where it's very dynamic applications. We want to be able to use message passing for isolation. That's one of the things that is staple in computer science, where that's how we know we do isolation, by doing message passing. And then finally, like plugins should be merely objects, right? That react to messages, react, no pun intended, to messages, right? So they can do whatever they want inside the object. They can have React components, whatever they want to do, but they ultimately should be all objects. And relatedly, representation in the plugins should be optional. We can have engines in the plugins. So what architecture would allow us to do this? So what architecture would allow us to hold and change layout state in memory? What architecture allows us to do message passing between plugins? Connect components to state and side effects? A couple of nice to have things, incremental loading, an architecture that allows for, you don't have to load the entirety of the IDE the moment you hit the page. On Repl.it, we do server-side rendering. It's the first IDE that does like server-side rendering, right? So we want to be able to kind of maintain that and do incremental loading. And we want to be able to have serializable state, so we can send it from the server to the client. We can save it. You can go to a different session and kind of serialize the state. So the answer here is Redux. And I know in the React community now, Redux is getting a lot of hate. But I think it's unwarranted. I think Redux has some really, really good decisions built into it. And a bit of a digression, I think that as a community, we need to kind of move away from this like hive mindset of something is either hot or it's garbage, right? So there's like something in between where we can be objective about things, right? So like if something solves a problem, then you should definitely use it. Some people would want you to kind of use the hot things in the community. Open source developers are kind of like, in some cases, a lot of them are really nice. I'm one of them. I worked on Babel. I worked on React at Facebook. I worked on a lot of open source projects. But one thing that open source developers tend to do, we're like teenage Instagram stars. We want likes. We want the new hot thing. So a lot of times, the user and the open source developers are not aligned. So all this digression just to say that if something is valuable, just use it. You don't have to kind of follow the latest trend. So I think I've been here. All right, so let's take an example. So here's the HTML environment. So we have a sidebar. We're going to ignore it for now. We have header. We have an editor, and we have a result, which is the output, which is the HTML output, and we have a console. Here's what the layout looks like in our system. Here's what the representation of it in memory. At the root node, we have a stacked split. It's a split between the header and the rest of the IDE. So we have the header as a leaf node. So here, leaf nodes are in blue. These are the IDE plugins, and the green nodes are window manager primitives. So we have splits, we have tabs. So we have a split between the editor and the tabs, and inside the tabs, we have two tabs, the output and the console. So what happens to this is we have the window manager React component, which takes in the layout. It also takes in the plugins, and figures out how to lay out the editor. So we have an in-memory representation of the layout, and we have the array of plugins, which are React components in this case, and then the window manager figures out how to render that. And that's actually React that's happening here. So what's in Redux? In Redux is the layout. It's also the plugins. We talked about incremental loading. We want to be able to incrementally load. We want to be able to hot load plugins. So the plugins are actually in the state. The layout is in the state. And the plugin state is in the state as well. So actually, let me pop over to the browser and just show you. We can just open Redux here and look at the state. So it's under workspace, layout. So we're in the layout. floating is this like floating component. So we have this, everything is squished now, but we have this help component that's floating. So that's what's floating in the layout. And then we have the tiling. So like I said, the split up front splits the left being the side pane, the right being the split between the header and the rest of the IDE. And then, so it's exactly the tree that I showed in my example. And sort of it keeps going until we hit the console. Here's the output pane. All right. So one thing I said we wanted to do was dynamic layout change. So for example, when we detect that we open a port, we want to split that view and like show you the web view. And what's happening here, I'm not sure how viewable is the code, but what's happening here is we're dispatching an action that's called load plugin, and that will load the web view plugin. And then if the layout doesn't have that plugin already, maybe it's already been loaded. So if it is not, then we go and insert the layout, insert the components into the layout, and then we dispatch an update layout. So that all happens inside the handler for the open port. We get an open port event from the server, and then we do this stuff. So the plugins part of this architecture, they're isolated from the world. They don't have access. The only thing they can do is receive actions. They build up their own state, and this is crucial, right? Like I said the isolation model should allow us to put the plugins in a worker or somewhere else on the internet. And so they should build up their own state from the actions that are flowing through the system. And they can do side effect via something we call receivers, which I'll introduce in a second. So isolated that you can put it in the worker. So I'm going to do a little bit of live coding, which is always tricky. So I hope nothing breaks. It's also in my local development environment, so there's a good chance it will break. So what's happening here is I have a component that's connected to the state. And so what I'm building is I want to build a component that would measure the time it takes to run a piece of code, right? So we want to have that component running time, X milliseconds or X seconds, what have you. So we have a component here. So I've defined my component. I've defined my reducer. Reducer takes it's just a Redux reducer, takes the state and takes the action. In this case, we have two actions that we're responding to here. Eval started, and that's when the run button is hit. And then eval ended, and that's when we got the result of the evaluation. And when eval started, we get the date, so we can measure. And when eval ended, we get also the date. And the components, we just have a running status, whether it's running or not, and then we have the time. And what I export is the component, the reducer, the name of the components, and the layout. So if I hit run, I now just like hot loaded this component into state. Like I said, it's like the plugins are in state, the layout is in state, so I can actually live code my IDE. So this is kind of a throwback to Smalltalk, where the IDE was bootstrapped, and you can kind of code the IDE inside the IDE. So okay, but this is not really interesting because I'm running locally, so the time is usually 1 millisecond or whatever it takes to execute this code. I'm gonna like go pop over to like a Python REPL that actually talks to the server and try to load that plugin. Oh no. All right, good. So this is just a regular Python REPL. I don't have UI for this now, but I exposed something on window. So I'm going to load the plugin that we just wrote. It's called run status. And so it just showed me the runtime of the thing that I just ran. So let's say like print 1. And it ran in 81 milliseconds. If I did something like import time, and then time.sleep for a second. And so it ran in 1 second, as we would expect, plus the round trip to the server. So this is how we build plugins. It's a pretty easy concept. And just like one more time to kind of show what's happening here, we have a component that's like a regular React component. And then we have a reducer. And that reducer is basically just taking all the actions and running through the system from the moment the workspace loaded and building up the state for that plugin. And a receiver is basically a middleware. Is basically this plugin's middleware. It's where the plugin would actually do stuff. In this case, this plugin is actually responsible for evaluating code. So don't actually do this, but when we get the action eval code, we're dispatching the eval code. Inside the eval code, we dispatch eval started, which is what we saw before, then evaluate the code, then end the evaluation. And that's all you need to write like a run button, right? And it's isolated, and it's not conflicted in any way with the rest of the system. So I already showed a couple demos, few demos that stuff we're working on. So this is actually like a couple of extern terminals running side by side. So we're able to not just like run the Monaco editor in the browser, but we're able to run extern. I'm an Emacs user, but my colleague is a Vim user, and he likes to troll me. So I asked him to do this demo, and then predictably he had to kind of throw a dig at Emacs here. And just like more mad science, like you can go inside the terminal to like a browser, Browse, which is a really cool technology, and you can like open up Google and do some other stuff. So what we're kind of evolving towards is this like highly configurable, highly programmable environments. We want to be able to be the IDE for the web, the place where a lot of people are starting their programming career. And we want to give them the power to program their IDE. We want to give them the power to kind of own it and write plugins for it. So thank you.